Hello everyone, here is a question based on octet rule. We have 4 different sets of classifications for molecules that are in list 1 and we have 4 different sets of molecules in list 2. We need to match these two and find out the correct option here. Molecules obeying the octet rule. That should be CCl4 and CO2 because in CCl4 we have how many valence electrons? We have 4 valence electrons for carbon and then 7 valence electrons for each chlorine atom. Altogether we have 32 valence electrons. We can make 4 bonds with chlorine, that accounts for 8 electrons, and then the remaining 24 electrons we can distribute it as 3 lone pairs each for 4 chlorine atoms. So, in that way we account for all the valence electrons. So, here for carbon we have 4 bond pairs, that means 8 electrons, and then for each chlorine we have 3 lone pairs and 1 bond pair, therefore 6 plus 2 8. So, all the atoms obey the octet rule here. Likewise for CO2 we have 4 valence electrons in carbon, and then for oxygen 6 valence electrons, we have 2 oxygen atoms, therefore 4 plus 12 and therefore 16 valence electrons we have in total for CO2. Carbon is less electronegative than oxygen, therefore carbon comes at the center, and then we can make 2 bonds with each oxygen atom, and then the remaining 8 electrons we can distribute it as 2 lone pairs each for oxygen atoms. Therefore, this also satisfies the octet rule. All the atoms satisfy the octet rule here. So, we have 4 bonds for carbon, that means 8 electrons. For oxygen 2 lone pairs, 2 bond pairs. Therefore, A should match with 4, and this means 2 is wrong, 4 is also wrong. Now, molecules with the incomplete octet. This should be BCl3 and AlCl3, because in the next classification it is mentioned that molecules with the incomplete octet with the odd electron. In nitrogen we have 5 valence electrons, and then in oxygen we have 6 valence electrons. So, therefore, the total number of valence electrons here for NO is 11, that means that it is a radical. And likewise for NO2 we have 5 plus 12, 17 valence electrons. So, there comes the odd number of electrons. Therefore, both NO as well as NO2 will not obey the octet rule, and we will have odd number of electrons there. So, for NO the 11 valence electrons we can put it this way. So, 1, 2, 3, 4, 5, and then for oxygen 1, 2, 3, 4, 5, 6. We can make 2 bonds and then 4 electrons. So, that accounts for 8, 9, 10, 11. Now, here oxygen will obey the octet rule, but around nitrogen we have only 7 electrons. Therefore, this molecule as a whole does not obey the octet rule, and we have odd number of electrons. Likewise, for NO2 it will not be obeying the octet. The nitrogen atom will not obey the octet rule, though the oxygen atom will obey. And this means that C should match with 1. And then molecules with the incomplete octet, that should be BCl3 and AlCl3, because here we have 24 valence electrons each. For boron 3 valence electrons, for each chlorine 7. So, 7 times 3 21, 21 plus 3 24 valence electrons. We can make 3 bonds with chlorine. Though chlorine atom would satisfy the octet configuration here, the boron will not satisfy the octet configuration. So, we have 18 electrons as lone pairs and 3 bond pairs, that accounts for 6 electrons. So, we have used all the 24 valence electrons. So, this does not obey the octet rule. We have 6 electrons and here we have 8 electrons. Therefore, molecules with the incomplete octet should be BCl3 and AlCl3. Therefore, B should match with the 2. This means that option 1 is the correct choice here. Molecules with the expanded octet should be H2SO4 and PCl5, because in H2SO4, this is the structure of H2SO4. So, this is an example of expanded octet, because we have 6 bonds, that means 12 electrons. Likewise, for PCl5 we will have 10 electrons because we have 5 bonds.